This is a video on ways to calculate the golden ratio. The golden ratio is a mathematical ratio which is an irrational number, meaning it cannot be expressed as a fraction or whole number as it keeps going on and on. It is often represented with the Greek letter P. The golden ratio appears in most areas of nature, artwork, architectural, and geometry. It is known to be first discovered by a Greek mathematician called Euclid, who coded the extreme and the mean ratio. Lucas coded the divine proportion. There are also other names for it. Now, let's calculate the golden ratio using the Fibonacci sequence. An Italian mathematician, Leonardo Fibonacci, discovered this sequence when he was solving the rabbit problem. He realized that if he starts with 1 and add the two previous numbers, he was creating a recursive pattern. So for example, to get to 2, it was 1 plus 1. To get to 3, it was 2 plus 1. To get to 5, it was 3 plus 2, and so on. While we explore the Fibonacci sequence, ignoring 0 and 1, we divide the Fibonacci number with the previous one. For example, 2 divided by 1 is 2, 3 divided by 2 is 1.5, 5 divided by 3 is 1.66, and so on. What do you notice about the ratio of the terms? Notice as the values of Fibonacci numbers gets larger and larger, approaching infinity, the ratio gets closer and closer to the golden ratio. Closely related is the Lucas sequence, discovered by Edward Lucas, a French mathematician. Lucas numbers have the same recursive pattern just like the Fibonacci sequence. The only difference is the starting values. While exploring the Lucas numbers, ignoring 2 and 1, we divide the Lucas number with the previous one. We also notice that the ratio gets closer and closer to the golden ratio as n approaches infinity. Another way to calculate the golden ratio is the golden rectangle. Suppose you have a rectangle, and if you cut out a square, the leftover rectangle has the same ratio as the original rectangle. That is why the special cutout rectangle is called the golden rectangle. The golden ratio here is calculated by the length of the long side divided by the short side, which is equal to the sum of the two sides divided by the long side. A visual way to see this is with these measurements. The golden ratio here is calculated by the long side 618 plus 382 divided by 618, which is approximately equal to 618 divided by 382. In real life, the golden ratio is seen in nature, such as in the sunflower, where seeds are arranged in a spiral way. Counting the spirals resembles the Fibonacci sequence. The golden ratio is also seen in artwork, for example, in this famous photo of the Mona Lisa. The golden ratio is also seen in architecture, where the position and the placement of columns is based on the golden ratio. Another way to calculate the golden ratio is the golden pentagon. The ratio of the diagonal of this regular pentagon to its side is the golden ratio. Following Ptolemy's theorem, for a cyclic quadrilateral that is inside a circle, the product of the diagonals equals the sum of the products of the opposite side. So, for example, the diagonals b times b, b squared, is equal to, now the sides, a times b, ab, plus a times a, which is a squared. Next, we bring everything to one side. We have b squared minus ab minus a squared is equal to 0. Next, we can divide everything by a squared. So we end up with this. We can also let b over a be x. If we do that, we end up with x squared minus x minus 1 is equal to 0. Notice that this is a quadratic equation. To solve this, first we can identify our values of a, which is 1, value of b, which is minus 1, value of c, minus 1. If we substitute this value in our quadratic formula, we are going to get this. And our value, since we are working with length here, we are only going to take the positive value. So our value here is the golden ratio. Another way to calculate the value of the golden ratio is solving the golden ratio equation. So we already know that P is equal to 1 plus 1 over P. So to solve this problem, first we are going to multiply by P both sides. So we are going to get P squared is equal to P plus 1. If we rearrange, we will get P squared minus P minus 1 is equal to 0. Notice that this is a quadratic equation and it can be solved by using a quadratic formula. So our values of A is 1, value of B minus 1, value of C is minus 1. So substituting this value in our quadratic formula, we are going to get P is equal to 1 plus or minus root of 1 plus 4 divided by 2. Again, since we are dealing with length here, we will only take the positive value, which is this value. Golden ratio is equal to 1 plus root of 5 over 2. Another way to calculate the golden ratio is constructing two identical circles with equal radii. Next, you can draw a perpendicular diameter passing through the center in one of the circles. Next, you can draw a straight line from the point it touches the circumference, passing through the other radius of the other circle up to the circumference. Zn divided by Mn is equal to the golden ratio. So, visualizing with numbers, let's say the radii are 5 centimeters. Notice that this triangle is a right-angled triangle. So, we use Pythagoras theorem to work out the missing side of this triangle, which is 5 root 5. So, therefore, Zn is 5 plus root of 5 divided by Mn, which is 10. To simplify this, you are going to get the golden ratio is equal to 1.618. Another method to calculate the golden ratio is the continued fraction. This is an iterative process where you add the integer part, in this case 1, and the reciprocal of another number, then again writing this number as the sum of its integer part and another reciprocal, and it keeps repeating and repeating. This golden ratio is such a beautiful infinite series of ones.